Before finishing off the obstacle class, all that's left to do is to create a custom hit test, since both of our objects and the gap between them is contained in one container. We'll start by ensuring we haven't passed the obstacle yet. So let's create our hit test function, which will return a boolean. And if the obstacle has been passed, we're going to return false right away. Next, we'll add a rectangle with the stage's parameters for stage coordinates. Const b rectangle equals this dot get bounds, brackets GUI module settings dot stage ref. Okay, now in our collision detection, we'll want to check three things. If the turtle's head is after the obstacle's left edge, if the turtle's tail is before the obstacle's right edge, and if both of these are true, we're going to want to retrieve the turtle's vertical position in stage coordinates. And we're going to want to check to see if the turtle is currently inside the gap. So if turtle stage x is greater than b.x plus game settings.obstacle side padding, this checks if the turtle's head is greater than the obstacle's left edge. And inside here, if turtle stage back is less than b.right minus game settings.obstacle side padding, this checks to see if the turtle's tail is less than the obstacle's right edge. Const t bounds rectangle equals turtle underscore ref dot get bounds brackets GUI module settings dot stage ref. This gets the turtle's vertical position in stage coordinates. And if t bounds dot y plus game settings dot turtle padding is less than top gap minus game settings dot obstacle top padding, or t bounds dot bottom is greater than bottom gap plus game settings dot obstacle top padding, will return true. And this last if statement checks to see if the turtle is currently inside the gap. Else, we're going to set past equal to true, and we're going to invoke the function game settings.obstacle passed. Else past equals true. We're going to have game settings.obstacle passed. Now, of course, before we move on, we have to create the game settings public static constants we reference. Let's go to the game settings class and do that now. So we have, under a commented heading titled turtle settings, let's create a variable called turtle underscore padding, and we'll set it to 30. And under our obstacle settings, let's add two variables, obstacle top padding and obstacle side padding. We'll set these to 20 and 25 respectively. Let's of course convert these using scaling factors in our init function. And let's create a public static function called obstacle passed under a new heading called score. We're just quickly adding this while we're here since we reference it later. We'll keep the function blank for now, but in an upcoming tutorial we'll use it to increment our score, update our score field, and play a success sound. Moving on to our obstacle manager. Our obstacle manager is the class that is going to manage our obstacles. Let's have it extend sprite and implement iAdvanceable. Let's also create some variables that we're going to be using. An array of current obstacle pointers, a full capacity boolean which will signal to us if all of the needed obstacles to be visible on stage were created, an obstacle speed variable with speed in pixels per frame, a stage width pointer, and a strike function that will be passing through the constructor function. We'll also create a static variable that will be our distance between obstacles. And then let's pass through our strike function in our obstacle manager constructor function. So let's set our underscore strike to strike. Let's set our stage width to GUI module settings.stageref.stagewidth. And let's set our distance between obstacles equal to stage width times 0.95 divided by game settings dot num obstacles, which is the number of obstacles we have on stage. This will calculate the distance needed between the different obstacles. And let's set our obstacle speed variable to game settings dot game speed times game settings dot obstacle speed multiplier. Let's also create these variables in our game settings class. Back in obstacle manager, let's create a function called createObstacle. This function will instantiate a new obstacle. It will add this child to the stage. It will set its position to the right of the screen, the added child, and it will push the pointer to our obstacle array. So const o obstacle equals new obstacle, which instantiates it. We'll add child o at the stage. We'll set the o position horizontally to GUI module settings.stageref.stagewidth. This sets it to the right of the screen. And we'll push our O object to our obstacles array. Next, let's take care of our advanced function. Inside of our advanced function, we'll create a for loop that iterates over all existing obstacles. This for loop will advance the obstacle by obstacle speed. It will hit test the object and carry out strike if there's a collision, and it will test to see if the obstacle is off screen. If the obstacle is off screen, it will regenerate the obstacle, changing the position of the gap and positioning it to the right of the screen. So public function advance, we've iterated over all existing obstacles, and in our for loop we've created a const o obstacle, which is this iteration in the obstacles array, o.x minus equals obstacle speed, which advances the x location by obstacle speed. And we have our hit test, which invokes strike if true. And if o.x is less than negative o.width, we'll invoke recreate, which regenerates the obstacle and changes the position of the gap. And we'll set o.x to equal to stage width, which positions the newly created obstacle to the right of the screen. Let's also add inside our advanced function, after we've closed off our for loop, a test to see if there are enough obstacles. So if we are not at full capacity, let's create an obstacle. So if full capacity is not true, else create obstacle. And we'll return true, of course, because this is an advanced function. And inside of our if function, we'll check to see if there is at least one obstacle, and if there is, we'll check to see if the last obstacle's x position is larger than the distance between obstacles. Which is to say, let's check to see if another obstacle should be entering stage from the right. And if last obstacle.x is less than underscore stage width minus distance between obstacles, create obstacle. After we find that the last obstacle's x position is larger than the distance between obstacles, and we create an obstacle, we'll test again to see if we've reached full capacity. So nested inside the function, if obstacles.length is greater than gameSettings.numObstacles, we'll set our full capacity boolean to true. Full capacity. Before finishing off this class, let's quickly create a play and pause function that will add our obstacles to our animator. And let's add a reset function. And that wraps up our 3 obstacle classes. Thanks for watching.